In this lab, we are going to practice implementation of another data structure called list. List is a generalization of stack and queue, which means that when we do stack data structure, we can retrieve or read the data from a certain designated end at the top of the stack. When we do queue, you can read or retrieve data only from the front of the queue. So you cannot read from any arbitrary position from the storage, but list is generalization. So you can add the data or retrieve data from any location in the storage. So we could do two possible implementations as we did stack and queue. In stack and queue, we did the first array-based finite implementation. Second, we did dynamic memory allocation based infinite stack or queue. But we could do similarly for list to implementation. So if we use array-based implementation, the adding the data onto the array is an easy process, and then the reading a data from any arbitrary location is a very easy based on index of the array. However, one of the problem is when you insert a new data into existing storage. Suppose we have stored data up to here, then inserting into at this location means we need to shift those data by one position to the right. We need to open this uh, storage, then we can insert that. So if we implement the list using array, then one of the non-trivial problem is insert operation. If we have a huge storage, suppose we have a 1 million data already stored, and then we want to insert the one data at this location at index 1, then we need to move huge number of data, close to 1 million data to the right one position. Moving those data to the right means for each data you need to move to the right one, and then next one to the right, next one to the right. So insert involves a lot of operation on moving data to open a slot at a given location. So we are not going to use actually array-based list implementation. In most practical implementation would be dynamic memory allocation based implementation like infinite stack and infinite queue. So in this list implementation, we are going to do singly linked list. Singly linked list. Here, linked list means data are stored in something like a node structure, and those data are linked together. So this node is pointing to the next node, this node is pointing to the next node, the very last one is a null pointer, and so on. So that's a linked list. Here, singly means we are going to have a one link from one node to next one node to next one. So that's one of the simplest implementation of a list. It's a singly linked list. Here, another complex implementation would be doubly linked list. Doubly linked list means there is a link from one node to the previous one. So here's node link to the previous one. So it's a linked forward and backward. Of course, data is stored in the node structure. So in the node structure, you will have a one member for data and then two members for links. So one forward, another backwards. That is a doubly linked list. In this lab, we are going to practice only singly linked list, the simplest implementation, and then you can easily extend the idea for doubly linked list. So in singly linked list implementation, so we are going to do something like this. So we are going to define a list class, and if we create list object or variable out of that, the list will have primarily two pointers. those pointers will point a node, and then data are wrapped by node, similar to infinite implementation of the queue. So each data, as they are stored into the list, so data are pointing to the next one and next one, and then the last one is null pointer and so on. And then in the list, the two pointers, we will call it as a head and the tail. And the head and tail are very similar to front and the back of the queue implementation. But in list, we use a different terminology. Head means the very front node. Tail means the very last node. But if you think head is a front, tail is a back, then the overall physical structure is identical to queue implementation. But because this is a list implementation, we will use a different terminology. So in list, the primary operation would be insert. So in insert, you specify where you want to insert the new data. So first integer would be position of the data to be inserted into the list, and then you give the data to be stored. So for this position for purpose, the node in the list, we assume array-like index. The very first node, we assume that this is a position 0. Next one is a position 1 and position 2 and so on. So insert operation, if we give position 1 data 25, then what we need to do is we create a new node where 25 is stored, and this node in the entire list should be at position 1. So currently the very first one is position 0, then new one should be position 1, and then those ones the position should be incremented by 1. So what it means is that we need to rearrange the link such that the very first one is pointing to the new one just created, and the new one should point to the one it was at position 1, and the rest we don't change. So insert operation is reorganize this link by adding a new node in between. That's insert operation. And then since this is a generalized implementation of stack and queue, so you should be able to read the data from any position. So get function with the position value as an argument, you should be able to read any data in any position. So those are two primary ones. Also, you can physically remove or erase a node at a given position. So you can erase 2 means the node at position 2 will be erased or removed. Then we should establish a bypass link from here, bypassing 2 and go to 3 directly. Then because of the link organization, so this position 1 remains, but position 3 should be changed to 2 and the like. So the primary operation insert and erase or get, those are the primary operations of a list. In the next video, we are going to implement the singly linked list.